This unit is all about area and perimeter of two-dimensional figures. The next unit after this will be like three-dimensional solids where we go 3D. So a lot of this unit is review for y'all, just finding the areas of the basic shapes. Sometimes you'll need to use our new area formulas like the Heron's formula or the side angle side area formula for triangles. So it kind of will bring together all the stuff we've learned so far. The area of a square is just the side squared. Area of a rectangle is the base times the height. The area of a parallelogram is also the base times the height. You have to be very careful on what the height is. It is the perpendicular distance between the two bases. So be careful when you're choosing the base and the height of the parallelogram. A lot of the time they give you extra information to confuse you. The area of a triangle is 1/2 the product of the base and the height. These are the other area formulas for triangle, Heron's formula, and the side angle side formula for finding the area of a triangle. Here we're going to do some problems to refresh your memory. We have a basic right triangle here with one of the sides missing. So you'll have to do Pythagorean theorem to find the side that you're missing. Remember, a squared plus b squared equals c squared, so x squared plus 7 squared equals 11 squared. And when you're solving this, you do want to do radical form. What you end up with is that x squared is 72, and then you square root that. And the simplest radical form of the square root of 72 is 6 root 2. So x ends up being 6 root 2. And it does have units. Watch for units, particularly on this area and perimeter unit, because that's very classic to have units on your figures and have to do meters squared for area, or perimeter would just be meters. So x is 6 root 2 meters, and the area of a triangle is the base of the triangle, which in this case is 7, times the height of the triangle, which is 6 root 2, divided by 2. So the way that I do this would be 7 times 6 divided by 2, and then just keep your root 2 because they do want radical form. So it's 21 root 2, and so don't forget your units, meters squared there on that one. On problem number 2, it's not a right triangle, but we do have the 3 sides, so we're going to use Heron's formula here. So we have to find our semi-perimeter first, S, which is to add the sides up and divide by 2. And what we get is 29 over 2. Now, since they had said to leave all the answers in simplest radical form, I do not want to get a decimal right now. I want to keep this ugly fraction here and work with it. So I'm going to move on with the Heron's formula, which is the square root of S, which is 29 over 2, times S minus each side. And since I'm having this 29 over 2, I'm going to have each side as something over 2. So right now I'm just going to set up for subtracting each of the 3 sides. And we'll fill in the blank right now. So 5 as something over 2 would have to be 10 over 2, because 10 over 2 is 5. 11 would have to be 22 over 2, because that would reduce to 11. And 13 would have to be 26 over 2 to reduce to 13. So now I'm going to simplify all of this, and I'm going to keep all my crazy fractions going here. So 29 over 2. 29 minus 10 is 19 over 2. 29 minus 22 is 7 over 2. 29 minus 26 is 3 over 2. So when you're doing a radical and you have a fraction, you can do the square root of the top or the square root of the bottom. So what I'm really looking at here, and I'm going to leave it as all these numbers because that's going to help me in my simplifying of my radical. Those are all the numerators. And the denominator is 2 times 2 times 2 times 2. So now I'm going to simplify my radicals and get my final answer. So on the bottom I have 2 pairs of 2's. And if you want to go ahead and multiply 2 times 2 times 2 times 2, you do get 16, and the square root of that is 4. Or you can see that there's 2 pairs of 2's, and that'd be 4 when you take them out and multiply them. On the top, each of these numbers is a prime number, and there are no buddies. So, none of them get to get out of the root. And so you would just multiply them together, 29 times 19 times 7 times 3, and you'll leave that under the square root because that will not simplify. And it's 11,571 under the root for the numerator and 4 for the denominator. So the answer we just write as 11,571 under the root and then over 4, and then that is meters squared. Don't forget your units. Always double check that you put them. The next one gives me the area, and we're having to find a missing piece of information. We're having to find the base. We know that the base times the height divided by 2 is equal to the area. And so we can multiply by 2, so we'll see that 5x equals 60. And then dividing by 5, x is 12, and that is feet, so 12 feet. On number 4, you can do this in different ways. You could do the side angle side area formula, but I'm not going to because they did say radical form on this one. You could do regular polygon apothem times perimeter divided by 2, but I looked at that and it gets a little bit ugly on this problem. So I find that the easiest route for this one is going to be Heron's formula. So each of the sides is 4. So the semi-perimeter is 4 plus 4 plus 4 over 2. So the semi-perimeter ends up being 6. And then we go into our root. 6 is the semi-perimeter. And then 6 minus 4 is 2, and 6 minus 4 is 2, and 6 minus 4 is 2. And so we get 6 times 2 times 2 times 2, which is 48. And when you simplify the square root of 48, you get 4 root 3. So the area is 4 root 3 meters squared for that one. The next one is a triangle, and we've got an angle measure of 52 in this angle here in the corner, and we have this side and this side given. So I'm going to use that side angle side area formula. And I'm going to have a decimal on this one because when you do the sine of the angle, you're not going to be able to have radical form. So it's going to be, the formula is 1/2 one of the sides times the other side times the sine of that angle. And that gives you the area. And they didn't tell me where to round to on here, and so I'm just going to go with 2 decimal places. 15.76 is what you'll get. So 15.76 meters squared. Not forgetting our units there. And then on number 6, they have a parallelogram. They gave me the area. The area is the base times the height. And so the base on this picture is the x and the height is the 6. They gave you this 7 to confuse you. We are not using that base because we don't have the perpendicular distance between the base on the left and the base on the right. So we are forced to use the top and the bottom as our bases. That means that 6 has to be the height. So the formula base times height is going to be 6 times x equals to our area of 54. And then when we divide, x is 9, and that unit was meters, so it's 9 meters for x. The next one, we basically have a rectangle on top of another rectangle, so we're going to divide this out right here. 6 is the height of the rectangle on the bottom, so this will be 6 meters, and what's up here, 10 minus that 6 will be 4 meters up here. So I have a square on top, 4 times 4, 16 meters squared, and I have a rectangle on the bottom, 6 times 12, 72 meters squared there on the bottom. And then we're just going to combine those two together, 72 and the 16, and get 88 meters squared for the total. On number 8, what they've done here is they've got a base and a height matching for each set of bases. They did not tell us the area at all. So this height matches with this base. So one way of finding the area is to do 8 times 9. So this is the area. Another way of finding the area is to use this height and this base. So that means that the area is the same no matter which base you're using, as long as you're using the height that it goes with. So the base of 12 with the height of x, that area should equal the area if you used the 8 times the 9. So it shouldn't matter which method you're using, you should come up with the same answer. So we're going to set these equal here. And so 72 equals 12x, and dividing by 12, 6 is x. So we're able to find that x is 6 meters.